The waiting times at a Perth Airport departure lounge have been found to be normally distributed. It is observed that passengers wait for less than 55 minutes 5% of the time, while there is a 13% chance that the waiting times will be greater than 100 minutes. Determine the mean and standard deviation for the waiting times at Perth Airport departure lounge. Doesn't seem like very good English, but anyway. So, I like to always sketch these things to get a clear picture of what I'm looking at. So, what we have here is a probability of 0.05, and that is for 55 minutes. And then over here for 100 minutes, we have a probability of 0.13. So we can say probability of x being less than, it's just less than 55 is equal to 0.05, and the probability of x being more than 100 is equal to 0.13. Now, a good way to approach this is to standardize. Go to the standard normal 0, 1. So what we get then is z is less than 55 take away mu over sigma being equal to 0.05, and the probability of z being more than 100 take away mu over sigma is 0.13. So 55 take away mu over sigma equals, and 100 take away mu over sigma is equal to, and we want those z-score values, which we can just get from the calculator. So let's see if I can get my calculator up here. Let's get rid of that because that was all rubbish from another question that didn't actually work out. And let's just go in here and we'll go inverse normal CDF. Leave the 1 and 0 because we're talking about standard normals. Left setting of 0.05 gives us negative 1.6449, and then do the same sort of thing with a right setting. So let's go to the right and have that one as 0.13, and that's 1.2639. And then these are just simultaneous equations, which we can solve on the ClassPad simultaneous equation solver, giving us mu is 81.7 and sigma is 16.2. Determine the probability that the waiting time will be between 75 and 90 minutes. So basically we use the values that we just got. X is a normal 81.7, 16.2 squared. Remember, because that's the variance, that's why I write the squared there. And then we're just doing the probability of X being between 75 and 90, and that's just a standard normal CDF on your calculator, and it gives you 0.3562. The mark scheme gave 0.3554, and I think that the difference here is just the accuracy of the figures that you use in doing the calculations. Quite often these things are quite sensitive to the number of decimal places you use, but they know that, so they give a bit of leeway with that.